Okay. Okay. All right. So as I said, we're gonna actually, I said that you didn't hear me because it wasn't recording. We gonna start with Visual Basic today, chapter 1 of Visual Basic, and chapter 1 is for the large part is a review to what we did in Technology in Action. All right. So we're gonna talk a little bit about computer hardware and software. We're gonna talk about programming languages in section 2. We're gonna talk about controls and programming. Visual Basic is a visual programming language that display lots of graphics, such as windows, text boxes, buttons. These we call them controls, right? So, so we're going to talk a little bit about controls and how to relate to Visual Basic. The important section that you need to do the first assignment for Visual Basic chapter 1 is section 1.4. So if there's one section that you need to study is section 1.4 to be able to do the lab assignment. And section 1.4 doesn't use Visual Basic. It's just you have to create a Word document to illustrate the how you would follow the programming process. All right, we'll talk more about that later on. And then we'll talk a little bit about Visual Studio. So in this chapter, we're going to talk about concept. We're not going to actually start writing programming, but I'm going to also write a program just to give you an overhead of what we're going to overview of what we're going to see in the coming weeks. So what is Visual Basic? Visual Basic is a software development system that allow you to create application for the Windows operating system. And the key in here is it allows you to create application for Windows, not for Macs or other platforms. So if you don't have Windows, you cannot run Visual Basic. Keep that in mind. Sometimes we call that VB. What can you do with Visual Basic? You can create Windows application, which is the only thing we're gonna do in this class. You can create database application. We're not gonna do that. You can create web application. Also, we're not gonna do that. And you can create graphic application. So the only application we're gonna do is Windows application. First, we're gonna do some review about hardware and software. This is from Technology in Action. We know that a computer, the computer hardware is what you can see and touch, is the physical aspect of a computer system. A computer system is not just one device, it is a collection of devices. For example, a computer system have a CPU, which is a microprocessor, which is used for processing. It have RAM or main memory to store data that the CPU work with. And it have secondary storage, which are like the hard disk and the optical drives that allow you to store data to storage devices. And you have input devices such as keyboard and mouse, and you have output devices such as the monitor and the printer. The things to remember from here is, and this is important things that I want you to remember, is the concept of input, processing, and output, because we're going to follow this methodology when we write program. In our program, we're going to have an input section, we're going to have a processing section, and we're going to have an output section. So always you have to remember these three part of a program, and you have to write them in that order. You do the input first, then you do the processing, then you do the output. In terms of hardware, the input devices are keyboard and mouses, cameras, tablets. Output devices are the printer, monitor, etc. And processing devices is the CPU and RAM. You have devices that are both input and output. These are basically secondary storage devices, are basically both input and output devices. What does the CPU do? The CPU is the brain of the computer. It is the central component of a computer. Without it, you cannot do any calculation. It is the most important component of a computer. and it functions to fetch instruction and execute them one by one. A program is a series of instruction that tell tell the CPU what to do. Instruction are stored in memory as binaries, numbers. Instruction are stored in 1 and 0. So this 1 and 0, we call them basically the machine language or the native language of a computer. Right. Of course, as a human, we cannot write programs in 1s and 0s because it's difficult to understand. But to a machine, 1s and 0 is a native language that they can easily understand. So anything you write in a programming language has to be translated to 1s and 0s in order for the computer to be able to run them. The CPU work closely with RAM, with main memory, which is the computer work area. It used to hold the program instruction and data that the program needs when you are executing a program. Commonly known as random access memory or RAM, the CPU can quickly access data at any random location. That's why we call it random access memory. It is things to remember. It is a temporary storage. If you shut the computer off, whatever you have in RAM disappear. That's why when we use Microsoft Word or Excel or Access, we had to save the work before we shut down the computer. Secondary storage is a non-volatile storage. It's permanent. This is where you save your work before you shut down the computer. It is mostly stored on a magnetic disk that record data magnetically. But you can have also external disk that connect to a port like USB port. You have USB drives that we used a lot in the classroom. And you have optical drive like CDs and DVDs that record data using laser beam. Input devices are used to collect data and send to the computer. Input is defined as any data that the computer collects from the outside world. All right. Common input devices are the keyboard, mouse, digital cameras. The disk drive can act both as input and output. So the disk drive can be input when you are reading data from it. All right, this is again quick review of what we did in technology in action. Output is any data that the computer sends to the outside world. These include maybe sales report, list of names, graphic images, or sound. Data is sent to an output device which formats the data and present it to the user. Common output device is the monitor and the printer. The monitor is known as a soft copy. It's used to create software copy. The printer produces hard copy. The hard disk can be an output device when you're writing to it. Software is the programs that tell the computer what to do. There are two kinds of programs that we talked about them in technology in action. System software or operating system, which basically manages all the computer hardware resources and their processes. Example of operating system include Windows, the Mac, the Linux operating system. Application software, on the other hand, are software designed to make the user more productive, like Microsoft Word, Excel, and Access that we covered. All right, so this was a quick review of what we did in technology in action, right? The important thing in here to talk about programs. What are programs and how do you write programs and what each programming language have special. So first we're gonna start by talking of what is a program, all right? As I indicated, hardware by itself cannot do anything. In order for the hardware to do meaningful work, you have to give it instruction of what to do. These instructions are known as programs. Another term is software. So they are instructions that tell the hardware what to do. So computers can only follow instruction. A computer program is a set of instructions on how to solve a problem or perform a task. Now, the question that many people ask is what who is a good programmer, right? A good programmer is a programmer that can come up to a solution to a problem. He doesn't really need to know lots of programming languages. What makes a good programmer is his or her ability to solve problems. So the first step in solving problem is to come up with a solution or logical solution that we call an algorithm to the problem. For example, if you want to compute the gross pay of an employee, how would you do that, right? Let me give you a hint because you're new to writing programs. So I'm going to go ahead and start. Okay. All right. It's just kind of a little bit when you're recording, it gets stuck. Okay. All right. So okay, I apologize for that. Sometimes the computer freezes when you're doing recording and doing presentation. But the thing in here, the problem is we're going to compute the gross pay of a person, right? Of an employee, right? Hourly employee, all right? How would you go about solving this problem, right? You have to ask questions. Remember I told you about formulating a problem in terms of input, output, and processing? This is you're going to need when you write programs. You have to ask the question, what is the input? What input do you need? What output do you need? What processing you need to convert the input into output? 3 questions you have to ask. What is the input? What is the output? What is the processing? When we talk about computing the gross pay of an hourly employee, the input is going to be basically how many hours the employee worked, okay? And how much is being paid per hour. So these are the input. This is what you need to know in order to be able to compute the gross pay. What you need for output is the gross pay. How much is going to be, how much gross pay he's going to earn. This is going to be the output. The processing is kind of link between input and output. How do you go from the input to produce the output? In this case, to compute the gross pay, you have to multiply the hours worked by the hourly rate to get the gross pay. So this is the idea of doing input, processing, and output, and you have to do it in that order, right? Okay, so let's go ahead and look at the presentation. So how do you come up, how do you compute the gross pay, right? The question is, first you have to ask the user to enter the input. Always you start with the input, then you do the output, then you do the processing. So you ask the user, how many hours did he work? This is one input, right? Right, let me go ahead and choose a pen. So in this case, you have one piece of input is the hours worked. This is one piece of input. So you allow the user to enter the number of hours worked and you store it in memory. This is an important thing, is you have to store it in memory. So program work closely in memory, work closely with RAM. So whatever you enter for hours worked, you have to store it in RAM. The second question, number 4, you ask is how much you get paid per hour? And you would ask basically for the hourly pay rate. There's another piece of input that you need to accept. So you get this input and you store it also in memory, right? And the third piece of information you need to do is you have to store the gross pay in memory. So gross pay is another piece of output that you have to store in memory. So these 3 pieces of information, the 2 pieces of input, hours work and hourly pay rate, and the piece of output, gross pay, has to be stored in RAM, have to be stored in memory, okay? Then you display the output in line 8 to store the information in RAM. Whenever you're talking about storing data in RAM, we are talking about variables. Okay. Let me remove the pointer. I guess when you do pointer, it just freezes the thing. Okay, and going back to this thing, these piece of information, hours work, hourly pay rate, and gross pay, you have to save them in RAM. You save them in RAM by what we call allocating memory storage in variable. Before you can allocate storage for this thing, you have to ask yourself what type of data are these gonna represent. You can have whole numbers. They are called integer data type. You can have real numbers that have a fraction, like maybe 1.5 minus 2.3. These are real numbers. Whole numbers are like 1 and 2, or -1 and -2. It doesn't have a fraction, but real number have fraction. These are defined as double or decimal type. And you can have a textual data, maybe the name of a person. This we call them string type. So these are important to remember, is what type of data are going to be in here. So in this case, for example, what type of data would be hours worked? It can be real or it can be whole number, but for the purpose of variety, let's assume it's a whole number, that you can work only whole number of hours. You cannot work a fraction of an hour. So you can work maybe 30 hours or 40 hours, but you cannot work 30 hours and a half, right? This is it can be an integer. Hourly pay rate, for the sake of illustration, we're gonna also say that it's gonna be floating point number. It's gonna be real number, so it can have a fraction. So you can be earning $24 and a half and 50 cents. So it's gonna be double, right? So how do we declare them? You have to declare for each input and for each output. You need to declare a variable. So in this case, we need to declare 3 variables: one for the hours worked, one for the hourly rate, one for the gross pay. Now, since the hours work we are assuming to be a whole number, we're going to declare it to be an integer. Notice the naming convention. Because it's an integer, we use int prefix to indicate it's an integer type. This is the hourly pay rate. We use a DBL prefix to indicate that it's going to be a double data type. And the gross pay, we use also DBL gross pay to make it to indicate that it is going to be a real number. Okay, so using a meaningful English name is important in programming. This is known as a programming style. So programming is not just a science, but it's an art. You have to write in a very clear fashion by using very easy to understand names, meaningful names. Now, what happened when you declare this variable? What happened is going to allocate space in memory. So you're going to have 3 spaces allocated in memory: one for the hours worked, one for the hourly rate, and one for the gross pay. Right? And these can be anywhere in memory. These are these funny numbers. Okay, you say, what are these? Okay, you don't have to worry about them. These are hexadecimal number. They are numbers that are base 10 and base 16 instead of base 10. So you don't have just only 10 digits, you have 16 digits. So you go from 0 to 9, then after 9 you go to letter A, B, C, D, etc. So that's why you see character in it. They're funny character. But just to illustrate how difficult it will be to write a program if you can now write it in machine language, you have to have addresses like these. But with programming languages, you use names like these. So it makes it much easier. So in a sense, a variable is a memory address. That's all what it is. And it's going to allocate the spaces for these memory addresses. Let me go ahead and go to the presentation and illustrate what happened when you run the program. So when you run the program, originally, you're going to have basically the memory is going to be all the content of the different variables gonna be not initialized. So you have question marks, right? So you have the question mark for hours work because you haven't stored anything in yet. Question mark and pay rate, question mark and amount earned. This is at the beginning of the program. At step 3, when you ask the user to enter the hours work, the user is going to enter the number of hours, maybe 20. So the hour content of memory location hours work is going to change from question mark to 20 because they have the input that the user entered. After you do step 6, which is store the hourly pay rate, the content of memory is going to change to whatever the user entered for the pay rate. Let's say he entered 25. So the content of the memory location hourly pay rate changed to 25. And after you do the calculation in step 7, that multiply the hours worked 20 by the hourly rate 25, the amount earned is going to change to 500, which is 20 times 25. So the memory changes. So this is a important thing to remember, that variables are memory addresses that changes as the program execute. So as the program execute, it changes from containing whatever is in memory to containing 20, 25, and 500. That's why we call them variables, because their content changes. Right, we're gonna do examples to illustrate that. But before we do that, I'm gonna go ahead and start doing something interesting. I'm gonna write a program in Visual Basic to implement that. So when you write a program in Visual Basic, you're gonna have a user interface. How are you gonna get the input, right? You're gonna have basically this kind of graphical user interface. We call it a GUI interface that describe where you're gonna get the input, where you're gonna display the output. So in this case, we have 2 input. These are text boxes. This is hours worked, hourly pay rate, and we have a label that represent the amount, the gross pay earned, right? Always input, you represent them with text boxes, and output, you represent them with label. The difference between text boxes and labels, text boxes, you can change their content. Labels, you cannot change the content. You cannot enter data in a label. That's why output always you want to declare as a label, because you don't want to allow the user to change the output. This will be calculated, right? And you have buttons that allow you to, when you click on the calculate gross pay, to do the calculation, get you the gross pay. And when you click on the close button, it will close the application. All right. So how do we write this program if we're gonna do in Visual Basic? Again, this is a preview of what we're gonna be doing starting next week. But I like to give you an introduction with Visual Basic. So we have the Visual Basic program. It's in here on the desktop. I'm gonna click on it. I have Visual Basic 2017. If you have Visual Basic 2019, it's gonna be a little bit different. Next week, I'll use Visual Basic 2019 to show you the difference. I'm gonna click on Visual Basic, Visual Studio. Visual Studio have in it Visual Basic in addition to Visual C++ and other languages. All right. So when we get to open Visual Studio, you can select to create a new project by clicking, or you can select to create a new project by clicking on File, New Project. When you get to that, you have to specify which programming language you're going to be using. Be very careful, because Visual Studio is not just Visual Basic, it has Visual C++, which is what's selected right now. I want to change from Visual C++ to other languages. Select Visual Basic. Make sure you select Visual Basic, first step. And then once you select Visual Basic, you want to select from the template on the right-hand side. Always you want to select Windows Form app.NET Framework. When you're using, if you're using Visual Basic 2019, you're not gonna see this thing that we did. You're gonna see automatically create new project, and when you click create new project, you're gonna get a list of different projects, and one of them is gonna be Windows Form app. You wanna select that. Right, I wanna select this one. I wanna select where I wanna save it. So I wanna do browse. And I wanna put it on the desktop. under COSCI 103. I will call it in here VB1. Create a new folder, call it VB1, Visual Basic Chapter 1. Open that. I want to put it in that folder. I want to select folder. Right. So I'm putting on the desktop under COSCI 103 VB1 folder. I want to give it a name. This is an application to compute the gross pay. I want to say here, I'm going to call it gross pay calculator. I use a meaningful name. It's represent gross pay calculator. I want to call it gross pay calculator. I want to say OK. And the first thing you're going to see is Visual Basic is going to create a window application, because that's what this template does. It's create a window application. So here it is. It create an application with a single window. Windows in Visual Basic are known as forms, and you can easily resize them by using the resizing handler. So you can have this small square in here, allow you to resize it, right? Now, the form, you can add control to the form by using a toolbox. Right now, you don't see the toolbox. To see the toolbox, you can click on View, and from the View menu, select Toolbox. Okay, and this is going to put the toolbox. It did put it on the right-hand side. I like the toolbox to be on the left-hand side, so I'm going to drag it towards the right-hand side. And when you get this thing icon, I want to put it to here, to this particular button in here, to put it on the right-hand side. Release the mouse is going to put it on the right-hand side, right? There's a data source which I don't use. I'm going to click on that and click on X to close it, because I don't use data sources. So I'm going to do that. Unless if you're doing database application, you're going to need that. For now, we're not going to use any database application in this class, so I close it. Other thing you need to see is Solution Explorer, which is fine. I have that, all right? But I still need a property window. So I'm going to go to View, and from the View, I want to select Other Windows, and from Other Windows, I want to select Properties window, and it's going to put it in there. So we have a property and we have Solution Explorer. I want to click on the push pen to hide it, so they hide now. But actually, I want to make them visible, both this one and the property window. Okay, so they will basically be stacked on top of each other. We have the Solution Explorer, and we have the property window at the beginning. What does the property mean? Okay, every control you see, which is the form control, and here is the window, the form control have property. When you select it, you're going to see a list of properties in here. For now, I want to minimize Solution Explorer. Solution Explorer will tell you what files you have belong to this project, and you have only a form right now. That's what it shows. Most of the time, you don't need to view it. I'm going to go ahead and click on the push pen to auto hide it. So it's going to hide it, so we have more room now for the property window. All right. So in the property window, each control have properties, and by default, they are listed by category. But if you want, you can change them, list them alphabetically, and it's a good idea to do that. Click on the A to Z button, and this will list the property alphabetically. And there's tons of property for each control, right? But for now, two important property I want you to be aware of. These are called the name property and text property. The name property is a way to establish a mean to refer to a control. You give it a name. By default, Visual Basic give controls meaningless names. So it calls label 1, label 2, text boxes, text box 1, text box 2, buttons, button 1, button 2, which are not meaningful. We have to change the names to give them meaningful name. Notice the name property is in parentheses, so it will appear at the top of the property windows. The other important property that we're going to learn today is the text property. The text property is allow the display of textual data inside the control. So anything you can see on the screen is a text property. So one important difference between the name property and the text property, the name property you don't see on the screen. It's just when you program, you're gonna use it. The text property is what you're gonna see on the screen, right? So in this case, when you look at this form, the text property of the form is gross pay calculator. The text property of this label is worked, hours worked. The text property of this button is calculated gross pay. So let's start with that. Let's go ahead and start and setting the text property of this form. The text property right now is set to form 1. I want to change that to say gross pay calculator. So to do that, you scroll through the property windows near the bottom to the letter T. Here it is, text property. You change the text property from form to gross pay calculator. When you do that, it's gonna reflect on the form. So again, the text property is what you see. It's gonna show it on the form. All right, so we need more controls in here, right? So if you look at the design, you need, let's say 1, 2, 3, 4. This is actually 2 label, 4 label control. You need 2 text box control, and you need 2 button control. So we need to add them. All right, so let's go ahead and do that. So in here, I click next to all Windows form, I click on the arrow. They're gonna show me all the available controls. First, I wanna add label controls. Here it is, label. I wanna double click on label. Before I do, double click on label, this is label 1. We need 4 of them, 2, 3, 4. So we have 4 labels. Because the font is too small, instead of having to change the font one by one, I'm gonna select the form, which is a container, and change the font for the entire form to bigger font. So if I go to properties and go to font, here it is, I can click on the 3 ellipses next to the font, and I can change the font to 12 point. Everything in the form changes to bigger font because it's a container and the label are inside the form. So I wanna move these around. And of course, I need to change their properties. Right, the first label, it should have a text, it should display hours worked. So I need to change the text property. Select the text property, and we'll type in here hours worked. Next one is gonna be pay rate. This one is gonna be gross pay. And this one, initially, I wanna set to zeros. $0.00. Now, so we have that. You can, if you want, select them as a group and move them if you want to reposition them. So I want to reposition these, reposition these, right? So you can, if you like, select a group of labels like these two and go to the format menu and select align, and you can align them to the right. So they align together. So there's different things you can do that. All right, so we have that. We're gonna add now the, this one is too big. I can resize this form. Right, now we need to add the text boxes, 2 text boxes. I can scroll to the toolbox here at the bottom. Here it is, text box. Right, I need 2 of them. I double click it twice, 1, 2. So we have 2 text boxes, and I can align them. Notice there's a lavender line that align it with the bottom of the label. You can align it with the center if you like, or with the top. Right, here it is. So we have that. And we're gonna add the 2 buttons. These are near the top. Here it is. 1, 2. All right, I need to resize them. Right, text property can be calculate gross pay. Right. This one I want to resize it. I need more room in here. I can resize the form. Resize this one. Right. And this one, of course, we need to resize it too. And I reposition it. This is going to replace that with close. This would be when you click it, it's going to close the form. All right. So this is basically just a basic look of this thing. I can reposition the whole thing. Right, so this is the form. This is user interface. So you can easily create that in Visual Basic. It doesn't take much, and you can easily do it. And mostly you would use in here the text property, because the text property allow you to set what you want to see. Right. Now, what we need to do is we need to name the control we're going to program. We know that this is an input, this is an input, this is an output. We need to name every input and every output. We need to give them meaningful name. All right. So let's go ahead and talk about naming controls. Control names, right? Control names must clearly describe what the control, describe the control in terms of the type of the control and the purpose of the control. So you want to use meaningful name. You cannot use any name you like, right? So you can, the control must start with a 3-letter prefix indicating the type of control. So if you have a text box, use a TXT prefix. If you have a label, use a LBL prefix. If you have a button, use a beta N prefix, right? All lowercase. Don't use any uppercase letter with a prefix, right? So you start the name with a prefix. Following the prefix, you would follow with a meaningful name. So if the text box represent hours worked, you would call it TXT hours worked. If the text box represent hourly pay rate, you would call it TXT hourly pay rate. Notice that you capitalize each word following the prefix. So the H in hourly is capitalized, the P is capitalized, the R is capitalized. This is required so you'll be able to read it. If you use all lowercase letter or all uppercase letter, you're not going to be able to read the words, right? And you may say, oh, I can use space. You cannot use spaces in variable names or in control names. So these are all valid names, right? Very important. A name can contain only alphanumeric character, that means alphabet and numbers, or the underscore character. This is the only thing you can use in a name. You cannot use spaces, you cannot use special characters, you can use only alphanumeric characters and underscore. So variable names or control names cannot have spaces. This is common error. The other thing has to do with good programming style. Even so, you can call a control anything you like with alphanumeric characters. You want to use descriptive name. You need to use all lowercase for the prefix. And you need to capitalize the first letter of each control. For example, in here, this will be good name, TXT hours worked, because it used lowercase for the prefix and capitalize each word. These are not good names. You cannot even read that. This is not a good name. You cannot read them. When you use them all uppercase letter or all lowercase letter, you're not going to be able to read the words. So use this methodology. Always write clearly. If you write clearly, you'll be able to understand your program. You'll be able to maintain your program easily. If you write unclearly, you'll have hard time maintaining your program because they are hard to maintain. So this is called poor programming style. You have to use good programming style. Let's go back to the application. So we're going to name all the input and output. So this one, we're going to name it. It's a text box. So what will be a good name? It will be, you have to use TXT prefix, hours worked, And this will be a text box also. We use a txt prefix, txt pay rate. And this one is a button. So you use a btn prefix, btn calculate. You can say calculate gross pay, or you can say just calculate. Calculate gross pay. And this is another button. I want to name it btn close. Right. So you need to name only the input, the output, and the buttons. You don't need to name the form. Notice if you select the form, it's called form 1. It's fine. You don't have to rename it. When you select these labels, since you're not going to program these labels, you don't have to rename. So if you look at this label, is named label 1. This is named label 2. This is named label 3. Since these you're not going to program, you don't have to name. You can use the default name, is fine. But this label, because it's an output, you have to give it meaningful name. So let's change this name. This will be LBL and gross pay, to present the gross pay, LBL gross pay. Right. So you have to name all input, you have to name all output, and you have to name all the buttons. So these are only things you have to name. So this is it. Now we have the user interface. We can run it. If you run it, you click on the start button, and this is going to compile the program, translate it to machine language, and then display the user interface. All right. So in just a few seconds, it's going to display the user interface. Okay, the first time it takes time to start, but once it starts, then it'll become faster. Right, so it's compiling right now, generating the machine code for the window application. And here it is. So we have in here the window, and I can put in here hours. If I put 40 hours at $20 an hour. All right. The problem, I haven't programmed this button yet. If I click on calculate, nothing happened. If I click on close, nothing happened. So I still have to write the program behind the interface. So the first step is very easy. It doesn't require any programming. You just create the user interface. Once you create the user interface, you have to program the buttons. They are called event handler, which is when you click on it, what would happen? When you click on this one, what would happen? We have to do that next. So I'm going to go ahead and close this one. And I want to do the programming. All right. So the first thing is to program the calculate button. Or what you have to do is you double click on it. When you double click on it, it's going to open the code window. Right. It's going to put you in the code window, and this is where you write your program. And you say, oh my God, this is something totally garbage to me. I cannot read that. What does it mean in here? Public class, private sub, all of this, I don't know that. Okay. All right. The thing, if you remember, I told you from beginning, remember 3 things. You have, every program should have an input section, an output, a processing section, and an output section. You have to do these sections. In addition to that, you need to have a declaration section to declare your variable. So this I'm gonna give you a template, more like cookbook. In steps, I'll put step 0. Step 0 is to declare your variable. What does it mean? Declare variables, right? Remember we talked about that in the Word document? At the beginning, this is declaring variable. Indicating for each input, what type of data you're gonna have, and declare variable for it. So we have 2 input, one for the hours is gonna be integer, one for the rate is gonna be double, and one for the output for the gross pay is gonna be double. So you declare for each input variable, for each input and for each output a variable. So we do that. You do them with a dem statement. You say dem variable name as variable type. Okay, so we have whole numbers are integer, floating real numbers are doubles. This is all what you have to remember. So let's go ahead and do that. So we have in here a bunch of dim statement. We say dim, and we're gonna declare an integer value for the hour. I use a prefix int, hours worked, as double, as integer. Notice Visual Basic have IntelliSense. As soon as you type int, it gives you integer, so you can tab on it if you like. Next one, dim, dbl, prefix for double, pay rate as DOU. Here double will appear in IntelliSense. I can tab, it's gonna pick it up. Dim dbl gross pay. Again, as I type D, it's gonna pick it up double. It remember the last thing I used. Press tab, you get it. This is step 0. Now it's gonna show you wavy line underneath each variable. Don't worry about it. This is telling you, if you move the cursor over it, it tell you a hint. It tell you that you haven't used the variable yet. All right, we're gonna be using it as we do step 1 and step 2 and step 0 of the program. So don't worry about it for now. All right. What's the next step? So we do declare variable step 0. Step 1 is, as I tell you, remember input, output, and processing. So step 1 is going to be input. By the way, whenever you put an apostrophe, you are indicating that you're writing comments, which are going to be ignored by the compiler. Whatever you see in green are comments. They are not part of the program. They are just documentation for you to know what you're doing. So we're going to do the input. And I'm going to give you in here cookbook syntax of how, what to use when you do input. All right, so I want to put the syntax to when you input in here an integer variable. When you read an integer variable, you have to convert whatever you enter in the text box is text. You have to convert the text into an integer. To do that, you use the CINT function to do that. So you convert the value from the text control dot text. You convert that to a integer. And if you're dealing with a double variable or real variable, then you have dbl variable equal, you use the cdbl function to convert it to double. I know it's kind of a little bit confusing at the beginning. Don't worry about it. We're gonna go to this thing from beginning next week. This is the syntax, more like a cookbook. How do you do that, right? So, all right, so in here, this is how you convert to a integer. This is how you convert to a double, all right? So this is not part of the program. This is comments. It's in green. So it's not part of the program. Now we're gonna write the program, all right? We have 2 input. We have 2 text boxes, right? We have 2 text boxes. So we need 2 input statements, one for the hours worked, one for the pay rate. So that's how we're gonna do that. First, we're gonna get the hours worked into int hours worked. Notice IntelliSense will detect the variable name. Press tab, you get it. And the hours worked, and we're gonna, it's an integer, so we use CINT to convert the text value to an integer. TXT hours work, it pick it up, press on tab, dot text. This will give you the first input. It will convert whatever text you enter in the txt hours work text box into an integer and store it in the int hours work variable. Notice int hour work now doesn't have a wavy green line because you have used it already. Let's do the next one. The next one is dbl pay rate. This is so we're gonna say in here dbl pay rate. Okay, it's a double, so you have to use a cdbl function. And we're gonna convert the text enter and txt pay rate control into double. And here it is. Now DBL pay rate doesn't have a wavy green line anymore because you have used it. Right? So these are the two input. We have two text boxes. So we need only two input statement. Right. Next step is processing. This is where the calculation, this is where you do calculation. The syntax in here is variable equal expression. In the processing section, you don't use any control, you use only variables. So you work only with variables, all right? So if you look at the declaration, we had the hours, we inputted that, we have the pay rates, we inputted that. All what you have to do is calculate the gross pay. This is what you're gonna do in processing. You're gonna do the calculation. DBL gross pay equal. Now the gross pay is gonna equal the hours work, INT hours, times the hourly pay rate, DBL pay rate. And this is gonna compute the gross pay. Notice the wavy green line underneath gross pay is disappeared now because we have used a variable. The last one, the last step is the output. And the syntax for that is the opposite as of the input. For the input, we set the control equal to the variable. For the output, you set the variable equal to the control. So in here, we're gonna say in here, I'm gonna give you different syntax in here. One, we can say LBL control. Output always is a label, as I indicated. That text is gonna equal numeric variable dot toString. This is one way you can do it. It's gonna convert to a string. But sometimes you may wanna, you can do more with the toString method. You can, if you like, use LBL control dot text equal numeric variable dot toString and use a format specifier with toString. You can specify that I want to display it as a currency with 2 digits of decimal point. And it's going to format it with a $sign and a comma separator. You can use many other ones. I'm not going to list all of them. We're going to get to that in chapter 3. But another one you can do, and I want to just copy that from here. You can use maybe maybe a numeric control, which will format it like currency, but without a $sign, without $sign. Other formatting you can use is you can format it as a percentage. Okay. And you can specify how many digits of decimal point. So all of that is a variable. All right. So in this case, we have one output. So LBL gross pay that text equal, and we're gonna format it. We're gonna use DBL gross pay dot toString, and we're gonna format it as currency with 2 digits of decimal point. And this is it. This is a program. It's gonna be able to display that. Right? So again, you have 3 sections: input, processing, and output. Before you do the input, you declare your variable. For each input and for each output, you declare a variable. Right? This is the program. This is the approach. I'm gonna go ahead and run it and see if this works. So now we did put an event handler to handle the click event on the calculate button. So when we enter the data and click on calculate, it's going to multiply the hours times the rate to give you the gross pay. Okay, right, here it is. Right, so let's say I work in here for 40 hours at $50 an hour. When you calculate, it's 40 times 50, right? It's going to give you 2,000. Notice it's formatted as currency with comma separator because you use a currency format in the toString method, right? Okay, so now the close button doesn't do anything because I haven't programmed it yet, but this one does work because I program an event handler. Let's go ahead and do the event handler for the close button so it does work. I'm gonna close this one. I can go back to the form and double click the close button to program it. But a simpler way is, and another way you can do that is from the code window without leaving the code window. You can click on this pull down arrow, select from it the button name, which is BTN close. And from the third pull down menu, select the click event. And this is gonna give you an event handler for it. And all what you have to do to close the form, every time you're gonna close the window or the form, you just simply say me.close. This one you can just memorize. It's gonna always close the form. So me.close, this will close the form. Me reference the containing form. This is a class, form 1. So when you say me, you're saying form 1. Close, that means close form 1 or close the window. Let's go ahead and run it, see how this works. Okay. All right, so I'm gonna put in here again, 40 hours at $58 an hour. Calculate gross pay, here it is. Close is gonna close the application. And here it is, it works. And we're gonna talk about programming. We're gonna go over this thing in detail starting next week, but just give you an overview basically how you do program. And I click on save all when you finish the project, click on save all to save the project. I'm gonna go ahead and minimize this one right now because it may need to go back to it, go back to the PowerPoint presentation and continue with this thing. We still have about 15 minutes and then we'll talk more about section 1.4, which what you need for the homework on Thursday. All right. So basically, this is basically the what happened in memory when you run your program. You have 3 variables: 2 for the input, 2 for the 1 for the output. So you declare your variable, and as you run your program, the content of memory changes. That's why we call them variables. Okay, how do you write a program, right? The native language of a computer is ones and zeros. This is how this is the language or the machine language that the computer understands. Obviously, it will be impossible for people to write programs in ones and zeros because it is very complex. So in order to do that, you would use a programming languages. So the step in a algorithm must be stated in a form computer can understand. All right, the computer understands ones and zeros, which is called machine language. Right, this is tedious and difficult for people to program. Right, so to help them program machines, programming language are available, which allow user to use more like English language to write program. If you notice in Visual Basic, the instruction are more like English. I mean, they're not They're not easy, but still much easier than writing in ones and zeros. What the programming language does, it simply translates the English words into ones and zeros so they can execute and run by the program. The special software called compiler convert the programming language statement into machine language. They translate them from English to ones and zeros. There's many programming languages available. Each one have some features. Visual Basic and C# are good in doing Windows applications, but they are Visual Basic is very limited in doing complex programming. Like if you're doing programming where you have to handle complex data structure, where you have to search the web for specific web pages. Visual Basic is very poor in that. C and C++ on the other hand, they are very powerful language. They allow you to do advanced programming that require complex data structure. They are very good at it, and they are efficient. Java is a good language to teach object-oriented concept. It is not that efficient. It is not efficient like C++ because it doesn't fully translate your program into machine language. It translates it into intermediate language that we call a bytecodes that still require further translation before it runs, which make it not fast, not efficient like C and C++. So that's very useful, very often used to teach object-oriented programming, but it is not that efficient itself. Python is a good language that for doing small graphic applications. PHP is good language to write basically server-side programs to handle a web application. And JavaScript is good to write client-side code inside your web pages to make them more interactive. There are more other languages, but each language have its feature. Today, we're going to learn, of course, in this class, we're going to learn Visual Basic, which is very good in developing Windows application, as you have seen in the example I just did. What does the program have? It have many things, such as keyword. If you remember, in our program, we use the word integer. We use the word double. We use word dim. We use the word sub. All of these are part of the Visual Basic language. We call them keyword or reserved word. These words you cannot use as variable names because they are part of the language. You have operators like multiplication, asterisk for multiplication, or addition or subtraction. These are all operators. You have variables like int hours work or dbl gross pay. All of these are variables. You have syntax, basically how you assign an expression to a variable. There are some rules that you have to follow. These are more like the grammatical rule of the English language. However, they are strictly enforced. If you make a single error, syntax error in your program will not run, will not compile until you correct all the errors. So Visual Basic can be very stubborn about that. So if you have a syntax error, make sure you correct it. Otherwise, you're never going to be able to run your program. It have statement, which are instruction made up of keyword, variables, and operators, right? For example, when I do the statement gross pay equal hours worked, asterisk, pay rate, this is an assignment statement that allow me to evaluate an expression and assign it to a variable. The statement together form what we call the source code, or simply the code of your program. The source code is more like English-like code. You have procedure. So we had two procedures in here. One of them to handle the click event on the calculate button. The other one was to handle the click event on the close button. So these are procedures. You have comment. These are ignored by the compiler. They are used for documentation purposes. In Visual Basic, commands, you create comment by using apostrophe in front of the comment, and comment will show up in green color. So comments are totally ignored by the program. Okay, user, the user are the people that use a program. The part of the program that interact with the user is called the user interface, right? If you create an interface that have windows and buttons, you're creating a graphical user interface, or what we call it a GUI interface, right? GUI is a GUI interface, and Visual Basic is all about GUI interfaces. In this case, your GUI interfaces will have a window, which is a rectangular area that contain other visual element such as text boxes and buttons. This is an example of a GUI interface. So it have text boxes, it have labels, it have buttons, it have a form or a window. Visual Basic is object-oriented programming language. An object is an item in a program that contains data and operation on the data. The data an object contain are known as properties. The operation an object can perform is known as method. So in this case, going back to the program, each one of these control you see is an object. This is a text box control object. This is a label control object. This is a button control object. This is a form control object. And each object have properties. When you click on the properties, you would see these properties. So in here for the, let's take the label control, for example, it have a property, if you like, called, in addition to the text property and the font property, it have a background color property. It have a foreground color property. So you can change the color if you like to any color you like. So you can change that. So a property is usually what does the object look like? This is what's a property. The property is basically what you see. It's what you look like. So you can have it black, you can have it green, you can have red. So it's called a property. It describes what the object is. A method, it describes what the object can do. For example, if you look at the close button, there is a method called close. This what it does when you invoke it, it closes the form. So this is a method. So a method is more like a verb, it's an action, and a property is more like a noun. It's always always a noun. It describes what the object is. A control is a specific type of object that in Visual Basic that usually appear in a program graphical interface. For example, in Visual Basic, the window you would see is called a form. Call it a form control, right? The text boxes where you input data is called a text box control. The area that display text that you cannot change is called the label control. The button that perform an action when you click them are called button controls. So in here you have, in the form, you see that we have 4 labels, 2 text boxes, a form, and 2 buttons. Visual Basic is an event-driven programming, meaning that when you click on an object like a button, it can execute a procedure to do something that we call an event. The GUI environment is event-driven. An event is an action that takes place within a program. All Visual Basic control are capable of detecting events, such as clicking a button, such as changing text in a text box. So we call them, basically, these are called events. The procedure that handle these events, the click event or the change event, are known as event handlers. Right. So in this case, the program, the 2 procedures we wrote are event handlers. Let's go ahead and talk a little bit more about controls and programming. There are many controls available in Visual Basic. We already seen the text box control, the label control, and the button control. But in addition to that, you have list boxes. We're going to talk about these that allow you to have multiple items. You have a combo box, which is a combination of a list box and a text box. You have radio button that allow you to select one from different mutually exclusive option. You have a check boxes. You have sliding bars. So you have many controls available. We're going to talk about them as we go along. You have to name control, use meaningful names, right? So, usually for text boxes, you're going to use a prefix. Text boxes use a TXT prefix, then capitalize each word, each following word, so you can read it. Labels use LBL prefixes. Button use BTN prefixes to use meaningful names. This is a recommendation. The first 3 letters, use it for prefixes. TXT for text boxes, LBL for label, BTN for button. All lowercase letter. After that, capitalize the first letter of each word. So a good name is TXT always work. This is much easier to read than all lowercase letter TXT always worked. So you can easily see that. You have to get to the habit of writing very clear programs, because if your programs are difficult to read, they will be difficult to maintain. We're going to talk about the programming process on COSCI. This is what you need to know for the lab assignment. So the lab assignment is creating a Word document. You're not going to do any program in chapter 1. So we're going to talk more about that on Thursday. That's all what I have for today. If you have any questions, let me know. I'm going to go ahead and stop the recording first. And then if you have any question, you can ask me.